Thank you, all of you, for coming here. It's really humbling for us to see this level of interest and support from all of you. I think we can only be successful together as partners. And again, just wanted to say thank you for making the effort to come here. Right, so I'm going to talk a little bit about our engineering investment in enterprise. But before I do that, I thought it's worth maybe a few minutes to talk about London. Why is Google engineering in London in the first place? And what are we doing here? And a little bit about the history of the office. As you heard from Dave, on this site we will be building a new office. And that level of investment has to be explained somehow. Well, it turns out that the digital sector is one of the main drivers behind London's economy. There are about 250,000 people employed in the digital sector in London. And that makes it the highest concentration of tech jobs in the whole of the UK. And we can safely say that London is maybe the digital capital of all of Europe, with thousands of companies based here, from multinationals like Amazon and Google and Facebook and Twitter, Snapchat as of last week, all the way to local startups that are growing quite fast, like Shazam and TransferWise and many others. And to fuel all this growth, London is home to an impressive 45 higher education institutions, and is home to 5 of the world's most prestigious universities. You have Imperial College, University College London, King's College, not very far, and then London School of Economics, London Business School. So it's quite impressive in terms of higher education. And at the same time, London is a tremendous metropolis. We are able to attract the brightest people from all over the world. Now, when it comes to Google itself, we have a number of offices here. We have started about 10 years ago, so actually more than a decade ago, in London, Victoria, so we went close to King's Cross. And the reason we started 10 years ago was because we were observing that more and more users were accessing Google properties through mobile phones. At the time, that meant Symbian, Series 60, it meant Windows Mobile. And we were also observing that 10 years ago, Europe was sort of leading the charge in terms of mobile technology. And that was the main reason why we started an engineering office focused on mobile in London. Fast forward to 10 years later, and we have about 1,400 engineers right now working on Android, of course, inheriting all that legacy of mobile experience. But at the same time, we work on things like Google Ads, on Google Maps, we work on Google Search, we work on a location platform, and many other products. When it comes to Android itself, we have about 300 engineers. All of them, this time located here at King's Cross. We have moved last year. And actually, all of engineering has moved to King's Cross. So 300 of our engineers are working on Android, and they work on all aspects of the operating system. They work from the system software, Java runtime, Java libraries, framework, all the way to applications like Google Play Movies or Google Chrome, Google Search on Android, or verticals like Android Wear. Now, drilling further down into our focus, Android Enterprise is one of the major charters that we have in London. And out of the 300 Android engineers, about 60 of those work on support for enterprise features across Android OS and Play. And some of you may recall that back in May 2014, we acquired a company called Divide. And I'm pleased to say that many of the engineers that work on enterprise features in Android come from Divide. They've been very, very successful. They're a tremendous group of people who have contributed massively to everything we have built with the enterprise support across Android and Play. Now, with 300 engineers, that makes us the largest Android engineering office outside of Mountain View. So I think that Android as an operating system has a very distinct British feel to it, actually very international, but also British. Much of Android is built in London. Now that you kind of know a little bit more about why we're in London at all and why are we working on Android here, let's take a step back and look at Android itself. We started about a decade ago, and what was it that we were trying to achieve? Well, Android is a Linux-based open source operating system created for a wide variety of devices with different form factors. Dave mentioned earlier that there are about 24,000 types of devices, so it's fair to say that that goal was actually quite successful. The goals, other goals of Android were to allow the innovation from our partners, from OEMs, from carriers, from developers, and give them the technical means to transform their innovations into real products that would really improve the mobile experience for users. Another thing we wanted was to make sure that the mobile industry isn't really restricted by a single player who could control the innovation and the products that other people wanted to create. So we wanted Android as an open source platform to be adopted by as many partners as possible and to create really amazing mobile products with it. We had relatively modest beginnings. That's the device we started with, the HTC G1. As you can see, back at 10 years ago, we couldn't quite decide whether it was a full touchscreen device or should it have a keyboard, so it had both. The keyboard was sort of sliding from underneath the touchscreen. So we started with one device, 0 users, and then that's how we got where we are today, actually. So 10 years later, there are hundreds of millions of smartphones shipped every quarter, and the price of a smartphone has actually decreased dramatically. You can buy a very powerful smartphone for under $100, which has tremendous implications for the entire world because it means more and more people have access to powerful computing devices. And I think Android has had a big role to play in this space. Now, as I mentioned earlier, Android is a Linux-based open source operating system, so most of the source code for Android is licensed under the Apache 2.0 license. And partners are free and encouraged to modify it and to add capabilities to it and ship products based on it. Now, Google is also adding things on top of Android, on top of the open source AOSP Android. And for instance, there's 2 main things that we're adding. One is a set of libraries and APIs that allow developers to embed the best of Google services on top of Android. So think, for instance, if you're developing an application and want to embed a map in it, then you would use the Google Maps API, or you want to embed ads. So all of these APIs, Ads API, Maps APIs, and so forth, are part of what we call the Google Play services. That's a library that sits on top of open source Android. The second thing that we provide on top of Android are applications, consumer applications, because we want people to experience the best of Google using applications built by us. So we ship Google Search on Android, we ship Google Maps on Android, Google Docs, and so forth. For every property that we have an Android app. Now, going back to enterprise, what this means is that the enterprise support we have built follows exactly the same pattern. Everything in the operating system that makes an Android device friendly to the enterprise is open source and part of the same code base as the rest of Android. And then, of course, all our mobile application management capabilities are part of Google Play services and Google Play application itself. And then finally, I wanted to reiterate the fact that like we have been very, very committed to creating a very successful ecosystem on a consumer space, we're equally committed to creating a very successful ecosystem in the enterprise space. We want to work with you, with all of you, to make a success out of Android in the enterprise space for our consumers and our enterprise users alike. So I mentioned enterprise users or stakeholders. Now let's see in a bit more detail who are these enterprise stakeholders. The way we look at it, we see 3 categories of stakeholders. In a company, of course, you have the employees themselves. And what do they want? They want to get their work done. They want the technology to help them rather than get in their way. And they want to do all of this while keeping the data secure and private. The personal data private, of course. Then we have the CIOs and IT admins, and what they want is to find the right devices for their employees, and they also want to control access to corporate resources like data and applications. And they, of course, want to keep all of the corporate data and applications secure. And then finally, we have developers. And of course, they expect Android to be a powerful application platform. They expect the best-in-class developer tools. And they also expect a thriving ecosystem where they can make a successful business writing enterprise applications on top of Android. So, okay, we understand who the stakeholders are. So what have we done in terms of engineering investment? Well, we have about 4 pillars, the way we look at it. So we have productivity, first of all. What this means is that we want Android to have best-in-class support for the basic building blocks behind productivity out of the box. So without installing anything, we want an Android device to be very capable when it comes to doing the basic things you might consider as productivity. So that means communication, time management, content editing. Then, of course, we want Android, not just for enterprises, actually, but for everyone, to be secure. So that's another important pillar of behind the technology that we're building. And then for those companies who want to have tighter control over how their employees are using those devices, we have built device management and mobile application management capabilities. Now, which use cases do we support? And then later we will see at a high level how these technology pillars I talked about map to these use cases. So, of course, you have a lot of cases where devices are being used for work without being managed in any way. So you have a lot of people who have Android devices, and they get the work done with them, and they're not under any kind of corporate management. This is typical for small and medium businesses, but is not restricted to them. A step further from that, you have the use case of employees who use their own personal devices to do work, but at the same time, they are under some kind of management from their company. Then further down, you have the cases where a device is completely under management. It's owned by the company, it's given to an employee, and is completely controlled by the company. And then finally, oh, by the way, this case has very different variants. For instance, you could have a company-owned device that's personally enabled, or a company-owned device that the employee has purchased, but then later expensed. These all kind of fit more or less to the same, under the same use case in our view. And then finally, you have devices that are owned by the company, but they are used either by a single employee for a single purpose, or they are shared among different employees, or they are not used by any employees at all. If you think of an advertising kiosk, for instance, or I don't know, a kiosk used for some other reason. Now, with these use cases in mind, let's talk a little bit about the pillars of technology and how they support these use cases. So for unmanaged devices, there isn't anything to manage, so I'm not going to talk about device management or application management. What I will say is that productivity is something we've been very active in working with our colleagues in G Suite. And all the G Suite apps like Gmail, actually Gmail and Calendar fully support Microsoft Exchange. And then Docs, Sheets, and Slides all work out of the box with Microsoft Office. So you can edit, view Microsoft Office documents. This has been a lot of work, actually, and we're really proud to have been able to extend the G Suite apps beyond the traditional functionality. In terms of security, well, this is the same. We have the same sort of concepts that apply also to consumers. So I said Android is based on Linux. So on Android, every single application runs in a separate process and runs as a separate Linux user, which means that you have kernel-level sandboxing for all applications. And on top of that, we have technologies like address space layout randomization. We have trusted execution environment to keep your cryptographic material secure. We have SC Linux policies. And these are all defenses that make it less likely for existing vulnerabilities to be exploited. And of course, like for those devices that support it, we have 30-day security patches to even close the vulnerabilities in the first place. And then we're also thinking that perhaps the best type of approach is to prevent harmful applications from making it onto the device in the first place. And that's why we have technologies like Verify Apps and Safety Net, and Adrian will talk about that in the next talk. Now moving into the managed space, we have Bring Your Own Device. And here, as I mentioned earlier, it's critical for an employee who uses their own personal device to do work to keep all their personal data and applications private, away from the control of the employer. So that's why we introduced the work profile concept. And you can see an example of the work profile on the image there. All the applications that have the little badge are working in a separate Android user, being away from the personal apps and personal data. So this kind of separation is very important for people who want to use their personal device for work. In terms of management, EMMs can have applications that run as an owner of the work profile, and all the corporate policies apply just to the work profile and not to the phone, to the entire phone. Now moving a level up from that, this is, by the way, a picture of an IT admin managing a fleet of devices. So in the case where the company owns the devices and gives them out to employees and then manages them. Here we have introduced a very powerful concept. It's a device owner. That is effectively an application, again, built by an EMM, that gets set up as the virtual owner of the device during the setup process. And what it can do is apply corporate policies to the entire device. And at the same time, it has access to powerful APIs. For instance, it can trigger a bug report remotely, or it can grab a process log. These are very useful from a security standpoint this time around, because it means that you can use this information as a building block, for instance, for building intruder detection tools. You can find out the processes that are starting or being shut down on an Android device. You can look at the lock screen activity. You can see what ADB activity happens on that device. So these are very, very powerful APIs that a device owner has access to, allowing an IT department to have a very sophisticated level of control over these devices. In terms of productivity, everything I mentioned in the previous use cases applies here as well. And then finally, we have the corporate-owned single-purpose devices. This is inheriting much of the same functionality I described for the previous use case. But at the same time, it's important to understand that these devices are don't necessarily have a human user using them all the time. So it's important for the IT department to be able to remotely manage these devices. That means running device diagnostics, looking at the temperature of the GPU or the utilization of the CPU, or recognizing that the device is in some kind of trouble and being able to reboot it remotely. So we have added support for all of this into Android. And in terms of mobile application management, we have built a lot of support into Play to allow IT admins to deploy applications to employees or to kiosks or to any kind of device. These applications can be hosted on Google Play, or they can be hosted on premises by companies who prefer to develop applications in-house and keep them on premises. They can still be deployed to their employee devices via Google Play, without uploading them to Google Play, by the way. Now, this overview, I think, shows, well, in some level of detail, the investment we have put into Android and Play when it comes to supporting enterprise. Now, what does the future look like? I think if you can all go back maybe to 1997, 1998, and remember a Windows PC with Windows 98 on it. Or maybe you can remember the workspaces of 10 years ago, where before mobile phones, smartphones, and tablets were being widely used. And I think you'll observe that the workspace has changed quite dramatically since then. Will it change from today? Of course it will change. And I think there are a lot of technologies that will transform the workspace as we know it today. Now, of course, like machine learning and artificial intelligence comes to mind, cloud computing, robotics, all of these things will transform the workspace. But these technologies don't really map directly to Android. So I thought, rather than talking about them, I'd talk about some new technologies where we're effectively teaching Android new tricks, and where Android will become very, very useful in the workspaces of tomorrow. So the first one of those is, and I think Dave mentioned that, the first one of those is where we're teaching effectively Android how to run on Chromebooks, powering Android applications on Chromebooks. Chromebooks are fantastic for productivity. They have a full keyboard. You boot them up in 2 seconds, and immediately you're there in the application you want to use. But we heard the feedback from our users who were saying that they want to do more with Chromebooks. They want to do a Skype conference call. They actually want to use Microsoft Office. Now, Skype and Microsoft Office are all available in the Google Play Store. So we thought, of course, if we put all the Play applications, all the Android applications on a Chromebook, then we open the door for a lot more enterprise use cases. And that's exactly what we've done. I think at CES we saw Samsung Chromebooks coming out with support for Android applications, and we'll see more and more of those. And I think this makes Chromebooks a perfect tool for those companies who are looking to replace their fleets of aging workstations and laptops. So I'm very, very excited about the future there. Now, another technology where we taught Android new tricks is virtual reality. Now, is virtual reality technology really new? What you're looking at is a Virtual Boy device built by Nintendo back in 1995. So you could argue that more than 2 decades ago, virtual reality, people were trying to build virtual reality devices more than 2 decades ago. Was this good? You can read the reviews for yourself. But it's interesting to note that more than 2 decades later, Google has announced that we have built a virtual reality platform. Now, that's called Daydream. Now, what took 20 years? Well, it turns out that to have a very good virtual reality platform, you need to have something called spatial immersion or presence. That's a way for the hardware to sort of trick your mind into believing that you're in a different place than you really are. And to achieve presence, there are a number of requirements. For instance, you need to have a device with a field of view over 80 degrees. You have to have a screen with the right resolution over 1080p. The device refresh rate has to be over 60 hertz. The pixel persistence has to be very low. The screen has to have low latency. And you have to have access to graphical APIs like Vulkan, that's part of Android 7.0. That again are very, very low latency. Now, this is what actually took 20 years. And this, in turn, all of these requirements put a lot of requirements on the hardware itself. So we have built support into Android for virtual reality, and our partners are coming out with devices that meet all of these criteria. Pixel is the first device that supports the Daydream platform, but then our partners from Asus, Lenovo, Huawei, and ZTE have launched already virtual reality Daydream-ready devices. Now, I'm really excited about this because imagine the future of communication. Will we all sit in front of flat screens talking to each other, or perhaps there are better ways, and so forth. Productivity, various other industrial use cases will be very, very well served by virtual reality, and I think Android is really leading the charge in this space. Now, related to that, and talking about another trick that we're teaching Android is augmented reality, Project Tango. What this means is that an Android device can sort of make sense of the world around it. It can understand the space it exists in, and it can start mapping it. It does this using 3 concepts: motion tracking, area learning, and depth perception. Motion tracking means that using cameras on an Android device, you can point it around the room and walk around it around the room, and the device will keep track of its position around the room simply by just looking at the surroundings. With area learning, the device will also remember everything that it has seen before, and at any point in time, if you show the same areas again, it will know where it is in that room. And with depth perception, the device starts to understand the shape of objects in that particular room. And then if you can start creating virtual objects, you can start interacting between virtual and real objects with an Android device. Now, again, this has tremendous applicability in the enterprise, and I wanted to show you a video of such an application that's been built by a developer partner. Could we please play that video?
Hi, so this is an app that we've been developing for this device. It's called Project Tango. It's something that's a development kit right now, but we're making an app available for a phone that's going to come out later this summer. And basically what it does is it allows you to visualize our products in 3D. So any of these that we have 3D models for, we can just select. So for example, if we're looking for this bar stool, and let's say we want this one, we can just load it up here on the floor, and it's going to load in.
That's great.
And then you've got the actual height. You can get up close and see the detail of the product and really know what it's going to look like before you actually purchase it. And we can also do lighting, for example, a ceiling light, and there's the light. So you can kind of examine that from any angle, and you can see what height it is and how it actually fits in space.
Let's pick a sofa.
Okay. So let's see, have any choices?
Let's
to
do
say?
this one.
All right. So basically just pick a spot on the floor. It's going to load that in. This is a little bit larger, so you can see it like load up the box.
Oh, that's
and
so
then
neat.
there it is. We can, rotate it. Put it over there. Let's rotate it a little more flush. Stick it against the wall. And there you go, nice underneath your light. And you get the
So
sofa.
cool.
We can also buy this, so you can add it to the cart, and it'll take you into the Wayfair app, where we can, check out and purchase this.
Oh, wow.
The sofa. Yeah, so it's kind of a complete experience.
Cool, thank you. And the last thing I wanted to talk about in terms of technology is security. I think it's enough to read the news these days to get an impression of how important that is. And as a company, we're completely invested in making Android devices as secure as possible.